I'm sure you've heard the news. You've probably heard that there's no gravity in space, but that's not exactly true. Gravity is everywhere, even in the vast emptiness of space. It's what keeps planets orbiting around stars and moons around planets. So why do astronauts float? In space, astronauts are essentially in freefall, constantly falling towards Earth but never hitting it, along with the Earth falling. So, it's not that there's no gravity, it's just Earth is also falling. In fact, everything is falling. But falling into what? Let me take you on a ride to answer this question in detail. Why is there no gravity in space? You are watching a H documentary. Hit that subscribe button and join the journey. There is gravity in space, lots of it. Gravity is everywhere. It is true that as you get farther from the Earth, its gravitational pull weakens. But it dies off quite slowly compared to nuclear forces. And gravity never goes completely away. When you get very close to some other large body, like the Moon, Mars, or the Sun, its gravity dominates over that of the Earth. Only then can you neglect Earth's gravity. Because gravity is everywhere in space, objects in space are always falling, towards the Earth, towards the Sun, and towards the galactic center. There are two reasons that objects seem to be floating without gravity in space when they are really falling. First, space is very large and relatively empty by Earth standards. When you jump off a bridge, you know you are falling because you feel the air whooshing up, see the mountains shooting up, see the water fast approaching, and then feel yourself hit the water. Because space is relatively empty, there is little air to feel whooshing past you as you fall, and there are no landmarks to indicate you are moving. Because space is so large, it takes you from hours to years of falling through space until you actually hit the surface of a planet, assuming you have aimed properly so that you actually do hit, instead of the seconds it takes jumping off a bridge. The second reason that gravity is not so obvious in space is because objects tend to orbit planets instead of hitting them. Orbiting just means that an object falls towards a planet due to gravity, and continually misses it. Because space is so large and planets are so small by comparison, it's actually very hard to hit planets. Space objects typically slingshot in hyperbolic paths around planets, or slip into orbits around them. It takes a team of scientists doing very accurate calculations to make sure a space probe destined for the surface of Mars doesn't miss it. Falling in circles around a planet instead of smashing into it doesn't seem like the gravity we're used to on Earth, but it's the exact same kind of falling. Astronauts in orbit around the Earth are not experiencing no gravity. They are experiencing almost all of Earth's gravity, but with nothing to stop them. This is known as freefall. Freefall looks like floating to a person in the falling frame of reference. Confusingly, scientists refer to an orbiting environment as microgravity. What they really mean is microacceleration, which is another term for free fall. This unfortunate naming convention arises from the fact that the word gravity is used historically to mean any acceleration, and not just gravity. For example, when an accelerating drag racer experiences 4 Gs, the acceleration is due to the spinning tires and has nothing to do with gravity. Artificial gravity is a concept often associated with science fiction, where spacecraft simulate Earth-like gravity for their occupants. In reality, implementing artificial gravity in space presents numerous challenges. The most practical approach would involve rotating a spacecraft to create centrifugal force, which mimics gravity. However, designing such a structure is incredibly complex. The rotation must be precise, as any imbalance could cause dizziness or nausea for astronauts. Additionally, the construction of a rotating habitat would require substantial resources, adding significant weight and cost to space missions. Furthermore, controlling the environment within a rotating spacecraft presents additional difficulties. The rate of rotation needs to be carefully calibrated to ensure that the artificial gravity is consistent and comfortable. Even slight variations could lead to discomfort or disorientation. Is gravity a theory or a fact? The story begins in the 17th century with Isaac Newton, whose law of universal gravitation described gravity as a force that acts at a distance between two masses. Newton's equations allowed us to predict the motions of planets and objects on Earth with remarkable accuracy, laying the foundation for classical mechanics. Fast forward to the 20th century, and we encounter Albert Einstein, whose theory of general relativity revolutionized our understanding of gravity. Instead of a force, Einstein described gravity as the curvature of space-time caused by mass and energy. His equations explained phenomena that Newton's laws couldn't, such as the bending of light around massive objects and the precise orbit of Mercury. But is gravity a theory or a fact? In the scientific world, a theory is a well-substantiated explanation of some aspect of the natural world, based on a body of evidence and repeatedly tested and confirmed through observation and experimentation. By this definition, both Newton's and Einstein's descriptions of gravity are considered theories. However, the effects of gravity are observable and measurable, making gravity itself a fact. We experience it every day, from objects falling to the ground to the orbits of planets around the sun. Theories of gravity explain these observations and predict new ones, continually refining our understanding. Ongoing research in physics, including the study of gravitational waves and quantum gravity. Where did gravity come from? Our journey begins with the Big Bang, the colossal event that marked the birth of our universe approximately 13.8 billion years ago. In the first moments after the Big Bang, the universe was an extremely hot and dense state, a chaotic sea of particles and energy. As it expanded and cooled, the fundamental forces of nature, including gravity, began to emerge, shaping the cosmos as we know it. Gravity played a crucial role in the formation of the first stars and galaxies. As matter began to clump together under the influence of gravity, it formed massive celestial bodies that would become the building blocks of the universe. These early structures underwent complex processes, leading to the creation of galaxies, stars, and planets. Scientists have proposed various theories to explain the nature of gravity and its origins. One such theory is the inflationary model, which suggests that a rapid expansion of the universe in its infancy set the stage for the gravitational interactions we observe today. Another idea comes from the realm of quantum physics, where researchers explore the possibility of gravity being mediated by hypothetical particles called gravitons. From Newton's law of universal gravitation to Einstein's theory of general relativity, each breakthrough has brought us closer to comprehending this fundamental force. In conclusion, gravity is a fundamental force that governs the motion of celestial bodies and keeps us grounded on Earth. While it may seem like there is no gravity in space, the truth is that gravity is present everywhere, but its effects are less noticeable in the vast emptiness of space. Understanding gravity helps us appreciate the delicate balance that allows our universe to function. As we journey through the cosmos, we see how gravity shapes the orbits of planets, the formation of stars, and even the paths of comets and asteroids. It's this invisible force that binds galaxies together and creates the intricate web of the universe. From the smallest particles to the largest structures, gravity plays a role in the grand design of existence. The more we explore, the more we realize how interconnected everything is. Gravity isn't just a force, it's a storyteller, weaving the narrative of our universe. It tells us about the past, the present, and hints at the future. Each discovery brings us one step closer to understanding the profound mysteries of the cosmos. So, as you gaze up at the night sky, remember that gravity is the unseen hand guiding the dance of the stars, planets, and galaxies. It's a reminder of the beauty and complexity of the universe we inhabit,